So today we're going to look at the mole concept. So the mole concept involves chemical reactions. And we can tell what's going on by chemical reactions. So these chemical reactions can involve gases, they can be done in solution, and these can then be represented by balanced chemical equations. If we look at the solutions firstly, the solutions the amount of a substance in a solution is determined by its molarity. So what is molarity? So molarity is the concentration in moles per decimeter cubed. So the molarity can be determined by titration. So how would you do that? So you'd have a substance of a known concentration or molarity, and you'd have a concentration or a substance of an unknown molarity, and then you'd titrate them against each other. And because molarity is linked by volume to the number of moles, you can then determine the molarity of the other substance. And again, you'll need a balanced chemical equation to do this. So looking back at our balanced chemical equations, so what does the moles of a substance, and how do we determine the moles of a substance? So the moles of a substance are related to the molar mass by grams. So many grams of substance makes up 1 mole, and that number of grams is called the molar mass. So that molar mass can be used in a branch of science called stoichiometry. Stoichiometry is a branch of chemistry which looks at relative quantities of reactants and products in a chemical reaction. So that's molar mass, moles, molarity, titrations in solution. So now let's look at what else we can do with a balanced chemical equation. So a balanced chemical equation tells you 2 things. It tells you the product and reactant formulae, and it also tells you the product and reactant ratios. So they are the big numbers in front of the formulae. So the product and reactant ratios can then be used to tell us about the formula units. So what is the formula unit? The formula unit is usually like an empirical formula that tells of an ionic compound, or basically the chemical formula for simple purposes. So what this does is it tells you, for example, NaCl, that we have 1 NaCl to every, or 1 Na to every Cl. So it's the ratio of ions in that compound. So that's the formula units. So the formula units is related to the number of moles by Avogadro's number. So Avogadro's number again then can be used in stoichiometry. And again there we can see that the formula units and the molar mass, the number of moles, are related together by Avogadro's number. Again, we can see the number of moles, which we saw earlier, is related to the molar mass by grams, and then that is then related to stoichiometry. So in stoichiometry, what can you actually do? You can use stoichiometry to calculate percentage yields. You can use it to calculate theoretical yields. You can use it to calculate the excess reagent and the limiting reagent. So what does all that actually mean? What that means is the limiting reagent is the one that once it's used up, the reaction can no longer continue. So it's limiting how quickly the reaction can occur. Not how quickly, sorry. It's limiting the reaction from proceeding. The excess reagent is the one that has stuff left over at the end. Okay, so you get all those big complicated reactions of stoichiometry, but they're all pretty straightforward if you think about them. Okay, so let's look back at our Avogadro's number linked with formula units and moles, which comes from our product and reactant ratio. So again, that's the numbers in front of the product and reactant formulae, the big numbers in the chemical equation. So now let's look at the products and reactant formulae. So we can also do what's called elemental analysis. So what is elemental analysis? Well, this is a quantitative analysis that tells you how much of every element is present in your formulae. Okay, there's a couple of different questions you can be asked on this. You can be asked about percentage composition, so they can tell you the number of grams and they can ask you to work out the percentage composition. Or they can tell you the percentage and they can ask you to work out the number of grams. Or what they can also do is they can ask you to calculate the molecular formulae or the empirical formulae. And again, the molecular formulae is a multiple of the empirical formulae, because the empirical formulae is the lowest possible ratio of atoms of each element in that compound. The molecular formulae, on the other hand, tells you the actual number of atoms or the number of moles of each, the actual ratio of each atom in that molecule, and that's it. So the ratio of each atom in that molecule, the actual ratio of each atom in that molecule. Okay, so that is quantitative chemistry, the mole, and how we can use chemical reactions.